Happy day and welcome everyone. What we're going to be talking about today is types of reactions, and there are 5 major types of reactions. So what we're going to need to be able to do is not necessarily write out what the reaction is going to produce, but you have to be able to recognize what type of reaction it is. So if we take a look at this worksheet, for example, in the beginning it's just going to ask us to label what the diagrams are. We're going to do that part together. What we're going to also do together is we're going to figure out what the giveaways are. If we can figure out what the giveaways are, then any equation that we're given, we can very quickly take a look at and see what type of reaction it is of the 5 types that we're being given. Okay, so let's take a look back at the notes real quick and see. So we've got 5 different types, just to kind of refresh our memory here. The first type is combustion. And with combustion, you are always reacting with O2, with oxygen. Now, you're not always going to do this little saying that we have, but I want to go over it. And the saying is, reacting O2 with cha or cho always produces co and ho, co and ho, co and ho. Co is CO2 and ho is H2O. Now, you don't necessarily have to, but if you do, you're going to get heat, you're going to have a flame, it's going to be an exothermic reaction, okay? If you have a reaction like methane, natural gas, which is the gas that flows through your homes, and you react that with oxygen, you just light it, and it starts reacting, you're going to get carbon dioxide and water with the heat and the light. And so that's how you can get your stove, for example, at home to give off heat to heat up your water for your mac and cheese or whatever it is that you're going to make. But this is also a combustion reaction. We've got iron reacting with oxygen. And when you react those two, you get rust. There has to be water present in the air, but you'll get rust if that happens. Now, you don't necessarily see a flame. You're not necessarily feeling a lot of heat because it takes a lot of time for the rust to form. But that is still considered a combustion reaction simply because of this oxygen that's on the reactant side. So that's going to be our giveaway that we have a combustion reaction. The next type that we have is single displacement. And in single displacement, I call this sports player substitution because one player is on the bench, another player is playing and they get hurt, you have to substitute them in. Now remember that the same type of player has to be switched. So aluminum is going to switch with copper because both of those are metals. Now don't forget, in that situation, hydrogen can actually do a little bit of both. Even though we consider it to be more like a non-metal, hydrogen can act as both a metal and a non-metal, just like our metalloids do, okay? And so you're going to see that they're going to switch places. And then double displacement, we also are going to have a switching of places where you can see that the lead and the potassium, same type of player, are going to switch places. I call this double dating, and here's why. In single displacement, you have to have an element and a compound. And remember, the difference is that an element is one capital letter and a compound has more than one capital letter. So like in this case, I've got zinc, only one capital letter, but then I have H and then capital Cl, which is hydrogen, and chlorine. So that's a compound. So if you have an element and a compound, you're going to get single displacement. But if you have 2 compounds like we do here, that's going to be double displacement. So instead of single, that'll be called double. So very similar, they're just going to switch partners. Now I want to make sure that I let you know, just like 2 plus 3 and 3 plus 2 are the same thing, these 2 could be switched here as long as they're both on the product side. And same thing here. These 2 could be switched as long as they're both on the reactant side, the entire thing. So it could say 2Ki plus PbNO3 arrow. That means the same thing. Okay, so I just wanted to make sure I let you know that. All right, the next type is called synthesis. And in a synthesis reaction, you're making one compound. You could actually have 3 or 4 reactants, but there's only one product on the other side, okay? And it could be exothermic, it could be endothermic, but we only have one product on the other side. Now, this reaction is special because it actually happens to be synthesis and combustion. Because it has O2 on the reactant side, if I asked you what type of reaction it is, it could be 2. It could be combustion and it could be synthesis, and synthesis because you're only making one thing. And again, don't worry about the coefficient here. It's just the fact that there's only one compound on the right. There's no plus sign. And the last type is called decomposition. And this is when you have one compound to the left of the arrow, no plus sign on the left, and it's making more than one product. So as long as, and you could have 3 products, you could have 4 products, but as long as you only have one reactant, that's something decomposing. So that's decomposition. let's take a look at some of these reactions then and see if we can figure this out. Okay, so we've got A plus B, and we can see that they're coming together to make one final product. Did you say synthesis? So hopefully you said synthesis on this one. Okay, let's take a look at the next one. It looks like there's one thing and it's breaking down. So we've got AB and it's breaking down. What do you think? Let's take a look at these. And did you say decomposition? It's one thing that is decomposing. So that one is going to be decomposition. The third one. So now we've got AB and we're adding C, but look what happens. A and B were partners before. Now A and C are partners and B is alone. We have one on the sideline and one playing, and then the person on the sideline comes in. That one is called, did you say single displacement? So this one should be single displacement. Let's take a look at the next one. We've got two couples here, but look what happened on the other side. They switch partners. So we can see that AB is no longer together. Now it's AC. So did you say double displacement on this one? Okay, so double displacement on this one. And now the last one, oh, there we go. I see the oxygen here. I see flame. Which one's left over? Hopefully you said combustion. That's the one that is reacting. And this one does happen to be, remember, it doesn't have to be, but this one happens to be reacting O2 with CH always produces CONH, CONH, CONH. And there's your CO2 and your H2O. Okay, so now what I want you to do is I want you to double click on this box right here. What we're going to do is we're going to write in what the giveaways are. So I'm going to give you a little bit of a tip as to how when you type things, how things can be kind of cool, and we can figure some things out here on typing it in. So I want you to hit the space bar a couple times, hit the plus sign, and then so shift with the plus sign right there, and then I want you to type O2. Now you can leave O2 like this, but if you're like me, you might want to do this as a subscript, and the way you do it is you find your control button, find just to the right of the letter M is a less than symbol. And you're going to hit those together, so control and then the less than symbol. And what it does is when you type the 2 in, it gives you a little subscript. Now to get out of it, you're going to hit that again. So it's the comma button, but it's the control and then the less than symbol. And now I'm back to normal, so I can hit my space bar. And now here comes another trick, okay? So again, if you don't want to, and you just want to type O2, that's all right. But if you do want to, then you can even do it after. You can highlight this, and you hit control and less than, okay? And that'll bring it back down. Okay, so now I need my arrow. To do an arrow, what you're going to do is you're going to hit the minus sign, which is to the right of the 0. So I'm going to hit the dash. I'm going to hit the dash again, so 2 dashes. And then you're going to hit shift and then the greater than symbol. And what is pretty cool is it automatically turns it into an arrow for us, okay? So again, the way I did that is I hit dash, dash, shift, then you do that greater than symbol, which is to the right of the M, it's the period, and then that gives you the arrow. And the giveaway for combustion is that we have oxygen as a reactant. Now, it can't be on the product side, it has to be on the reactant side, and it also can't be like CO2 or, ClO2. It has to be specifically O2. It could have a number in front. That's fine, that's a coefficient, but it cannot have any other elements in there, okay, or in any other proportions. And that's our combustion, okay? All right, now let's try single displacement. So for single displacement, we said that there was one element that was sitting on the sideline. I'm going to write that as EL. I'm going to have a plus sign. And then we have capital CM, lowercase, capital PD. The D is lowercase. Make sure you have 2 capital letters. The reason why I'm typing compound like this is because I want you to recognize that it has to be at least 2 capital letters, whereas an element is only 1. Then we're going to do the same thing we did before. We're going to hit the minus sign, which is the dash, the greater than symbol. So remember, what that looks like is dash, dash, greater than, but if you do it all at one time, it will actually switch it to an arrow for you, okay? Now, since we have this already done, and that's it, that's going to be your giveaway. If you see an element in a compound to the left, you don't really have to look to the right. The only thing I would check to see is maybe you're only making one compound. You have to be careful with that because maybe it could be that it's actually synthesis. So we'll go over that in a second. I'm going to copy this and I'm going to paste it for my double dating, because the only thing that's different about double dating that's a giveaway is this has to be compound, but you do have to end with 2 compounds. So if you don't end with 2 compounds, that's not double dating. Same thing with single displacement. You have to end with an element and a compound, but they switched places, okay? So you do have to look to the right also, but this is the best giveaway, all right? Synthesis. We don't really care what happened on the left, but we do care about what happens after the arrow. So let's do a dash greater than symbol, and now I have only 1 compound. Okay, again, you could have a coefficient in front. It could be a 3, it could be a 2, it could be a 4, but there's only 1 compound. And the last thing is, for decomposition, it starts with 1 compound, and then we have the arrow, and then you can have multiple things. Okay, so if it's decomposing, you start with 1 thing and it breaks up. If it's synthesis, that's the opposite. You could start with more than 1, but you end up with 1. Okay. In combustion, anytime you have oxygen on the left of the arrow, that's combustion. That's something that is going to be burning or giving off heat when it reacts. Single displacement and double displacement, they have to switch places. So you do have to check on the right to see what happened. Okay. All right. So once we save and close this, then what you're going to do is you're going to try to see how quickly you can match these to one of the 5 using your box right here. Now I will tell you that if you scroll down a little bit, I want you to try numbers 1 to 5 on your own and see if you get the right answers. And as long as you get these right, you should be good to go for the rest of them. So don't look at those answers until you're sure that you've got those down first. And some people will say, oh, you know what I do is I find all the combustion ones first. Then I find all the single displacements. Then I find all the, totally up to you. You should be really fast though. It should be pretty quick. So some people will finish the rest of this worksheet in under 3 or 4 minutes. They'll be pretty much done, okay? All right, I hope this was helpful to you, and I hope you've got all the reactions down now and you can recognize what they are. Happy day, everybody.